earbuds, all that stuff should be away, please. So what about this now? Let's take a second and let's talk about this problem. I kind of like this because it's an actual math model. So this is what math is used for. So John paid a landscaping company $248 for an initial lawn treatment, then $27 per month each month after that. Okay? They give us the function here. And you guys have actually built some functions like this last unit. So you got some familiarity with this, right? So here's our function, C of t equals, and that's, I thought I fixed that. Why is that showing up as an X? Okay, I'll fix that today. I thought I fixed that. It should be a T, right? It's a minor thing to fix, but I thought I did that. Guess not. I'll fix it. Easy to do. C of t equals 27t. I'll make that a T. Plus 248 represents the total amount of money he will have paid after t months. Okay, now which is when you look at this function up here, which is the input variable? Well, but the variable. You're right, 21 is the value, but which variable in this function is the input variable? It's easy to tell. T, right? How do you know? Because it's right there, right? So the input always goes, in the function notation, it's what we're inputting into the function. It's in the parentheses, right? Okay, so we're inputting t's, and what are we outputting? C, right? Or C, either C or even C of t, right? So the output is C of t, the input is t. What does t stand for?
It's months.
Months, okay? So it's time measured in months. How long has he had this contract, I guess? What does C stand for?
The bill.
Yeah, and I want you to see this connection here. It says the function C of t represents the total amount of money he will have paid, right? It's t that's the input after t months. That's the input variable, right? So then C of 21, what do I do?
Plug it in.
Plug it in, right? All that's saying is we're going to evaluate this function when C equals 21. And I gave you the Desmos graphing utility to use on this problem. So let's just one more time get a little practice with that, right? All we're going to do here is I'm going to define the function. So there it is. C of t equals 27t plus 248. Okay? Now what do I do? C of 21. I defined the function in Desmos, so I got to tell it what is C of t, and then I can come down to the next line, and Desmos is smart. It knows that if I do C of 21, C of 21, it's going to tell me what the value is. So it's 815, right? We know right away that this value is 815. Okay? What does this value represent? So 815 is a value of C. Thank you. You told me just a second ago that C, the function represents the total amount of money he's paid after t months, right? Total amount of money. So then which of these options makes sense? 815 is what? It's the input or the output of the function? You're right. It's the output, isn't it? We're inputting a 21 and we're outputting 815. So 815 is the value of C, isn't it? So what is that? What matches what C means? Is it the number of months John used the service? No. What's that? What is the number of months he used the service? 21, yeah. Is it John's cost per month for 21 months of service? That sounds pretty good, but cost per month isn't really what that is, right? This is a total cost. Okay. Is it John's bill for 21 months of the service? Yeah, that's it, isn't it? That's the total cost, isn't it? And then this last one makes no sense. John's bill regardless of how many months he's used. Well, no. It's the number of months he uses the service is going to change their bill, isn't it? Right? So it's got to be that guy. Okay? Okay, last one. His bill last month was $1,490. John had used the landscaping service for blank months. How are you gonna do that?
Subtract 248 and then divide it by 27.
Okay, so, but how are you getting there? What are you doing? Where am I gonna plug, what am I looking for here? They wanna know how many months did we use it? I'm trying to find a value of C or T then. T, right? T is the unknown. We wanna know how many months. So we're looking for T. What is 1490? Is that a value of C or T? That's C, right? So all we've gotta do here is we've gotta plug this into the function for C, and we're gonna solve for T, right? So we'll take our original function up here. C of T equals 27T plus 248, and we're gonna plug 1490 in for C. So we get 1490 equals 27T plus 248. Solve for T. What are the two steps to solve for T? Subtract 248 and divide by 27, right? So we could get it using algebra, but we could even use technology on this, right? So if we want to take advantage of Desmos, which we probably do, then what can we do? Well, we've already got the function graphed there, right? So all I want to do, if I want to solve, remember our trick, if I want to solve an equation, right? So I've got 1490 equals 27T plus 248. Well, there's the left side of the equation I've already got graphed. I don't even have to call it C of T. I can just call it Y if I want it for this part, right? I can come down here. In fact, I'm going to do that just so you can see how this works. Whenever we're solving an equation, we're just going to set the left side of the graph equal to Y. So I get Y equals 1490. And I'm going to set the right side of the equation equal to Y. Y equals 27T plus 248. Okay? And let's turn off all these other graphs up here. In Desmos, if I go, see what I did that? If I click on the gear, I can go down and change the colors. I'm going to make this one red, and I'm going to leave that one purple. How about it? Actually, I got to flip them around. Oh, that's right. Purple, that worked out great. Purple's the number. And then I'm going to go ahead and click this to turn that one off. So now if I go down to my graph, I got to zoom out quite a bit. But there it is. There's my intersection. If I zoom out really far, I can see my intersection. Right, there's the purple graph, and there's the red graph, and there's the point of intersection. Okay? So explain to me, let me take a picture of that, how about? It's a little messy. So what does that mean? Picture this too. Just for the notes. If you want to look at this later, it'll be in the notes. Okay, so interpret that. What does this ordered pair mean? What's the 1490? Yeah, that's the Y value, isn't it? Right? The ordered pair there. So Y we know is the output, so that's the cost. What's the X? Or T, I guess. What is it again? Months. Yeah, that's it, right? It's 46 months. All we wanted was the X value, or in this case, it's not X, it's T, but we're solving for the input variable. Normally it's an X, in this case it's a T. And so there it is, right? 46 is what goes in there. Okay? Make sense? Okay? All right, on to today's stuff. So go ahead and get out your notes. If you didn't get one of these, it's the packet up here. We're gonna move on to linear equations. Yes, sir. Yeah. Moving on to linear equations. This ought to be stuff you've seen this probably more than anything in algebra. So this ought to be very familiar, shouldn't be a big deal. Might add a couple little tweaks to it and kind of refine some things, but a lot of this should be reviewed. So obviously a linear relation, the graph of a linear relation is what? What's it look like, the graph of a linear relation? It says it right in the title. What is it? It's a line, yeah. Linear means line, right? So a linear relation the graph looks like a line. We can write linear relations with equations, and we have different forms of these equations that we're going to talk about. There's a total of 3 different forms of linear equations that are useful to us. Today we're going to work on the 2 that are probably the most common, okay? First one is standard form. So standard form, you may not have ever seen standard form. Raise your hand if you remember talking about standard form in Algebra 1. Maybe a little bit? Okay. So standard form is this. Standard form is the form AX plus BY equals C. And you write the A and the B and the C as capitals in standard form. So they really stand out as constants. So that's it. Now there are 3 rules about what values the A and the B and the C can have, how we have to write those. Okay, the first rule is that they have to be integers. So there's rule 1, have to be integers. Rule 2, A has to be positive, can't be negative. Okay, and then the last one is the one that people are probably the most likely to forget about, and that is that the greatest common factor of A and B and C has to be 1. Okay? So let's just practice a little bit, and this is nothing other than just using your awesome algebra skills that you've honed throughout the year so far. And we're just going to put these equations into standard form. Before you do that, though, think about the characteristics of standard form. What does it mean? The x term and the y term are on the left, and the constant c is on the right of the equation. That's it. And a has to be positive. It's got to be an integer. Okay? So let's look at a few quick examples. So what about this first one then? What are the steps I have to go through to put that into standard form? What's wrong with it right now? What's in the wrong place? The y is probably okay, right? Because the y wants to end up on the left, but what's wrong? Something's out of place there. Okay, the x needs to be on the left too, right? The x term and the y term need to be on the left and the constant on the right. So what am I going to do then? Okay, good. I'm going to move the x's to the left by subtracting 2x from both sides. Okay. And then that's going to give us, over here I've got a y plus a negative 2x. But let's go ahead and flip those around so the x term comes first, right? So we're going to do the negative 2x plus y, right? Does that make sense? When I subtract something, I'm just adding a negative. So subtracting 2x from both sides is the very same thing as adding a negative 2x to both sides. Okay? On the other side, the x's cancel, and I get a negative 9. Okay, that's much closer, but there's still one little issue here. Which of our rules up there have we not followed yet? Okay, a needs to be positive, so what's the very last step then? Divide by negative 1 or multiply by negative 1, same result. The outcome, what does it do if I have a bunch of terms and I multiply or divide by negative 1? Yeah, it changes the signs, right? So that, whoops, what's that? So the negative 2x becomes a positive 2x. What's the plus y become? Negative y. And on the other side I get positive 9. There you go. And now we're good, right? See, that's in standard form. Follows all the rules. What about number 4? A couple things you got to do there. What's the first thing we probably want to do? Add 7x to both sides. Good. So we'll add 7x to both sides. Now what am I going to get on the left then? 7x plus 7y. Put the x term first. And on the right, 7. Looks pretty good, but what's the rule we still haven't followed? A is greater than 1, that's good, A is 7. But there's still something wrong with this. This is the sneaky one. Common factor. Yeah, the greatest common factor of A and B and C has to be 1. Well, what's the greatest common factor of 7, 7, and 7? 7, right? 7 is the biggest number that divides into all 3 of those. So I've got to, what do I do then? Divide by 7. Exactly. I'm just going to divide each side through by 7. And if I do that, on this side it's pretty obvious. But what about over here? Now let's talk about this for a second. Dividing both sides by 7 means that, doesn't it? Okay, but when I'm dividing the left side by 7, that's not a very convenient way to write it. A common denominator, think about the word common. The word common means shared, right? If you have let's say you have a common bathroom with somebody, you're sharing that bathroom with them. If you're in college and there's like a common area where all the students can go, that's a shared area, right? So if it's a common denominator, it's a shared denominator, but each term has ownership of that, right? So I can split that up into 2 terms, and that's a better way to do it. Rather than do it this way, we probably instead want to write this as, we're starting here. We had 7x plus 7y equals 7. When I'm dividing each side by 7, let's just divide each term separately by 7. That's nice, because then we can easily, we can easily cancel vertically and reduce fractions. So what's our final result then? X plus y equals 1. Good, and we're done. Okay, last one, probably the toughest one. So what about this guy here? It's in pretty good shape. It follows rule 1. Actually, it doesn't follow rule 1. Those aren't integers, is it? It follows rule 2. A is positive, and it follows maybe rule 3. It's hard to even tell with rule 3. But what's wrong with that, obviously? It's not even worried about what rules it's following or not following. What's obviously wrong with that? What's the big red flag here? Fractions. We got to have integers for A and B and C, right? Now, this is something I've kind of forced you guys to become pros at this. Normally this is a little bit of a sticking point for algebra students, but I feel like you folks are getting to where you can do this pretty well. How do I clear those fractions? It's useful here because we got to get rid of fractions. Yeah, times what? Times it by what? By 12. Good. And it occurs to me that I think a better way to write this maybe is like this. When you're multiplying both sides, I think do it like that, because then you remember that you have to distribute the same number to both sides. And that's one of the mistakes I've been seeing, is that sometimes people are wanting to multiply the left side by one number and the right side by another. So instead, even though this isn't really mathematically valid work, technically, I think it's a good way to do it, because it forces you to remember that I'm multiplying everything by the same number, which is going to be 12. You're right. The smallest number that 3 and 4 divide into is 12, right? Other part of this now, when I distribute, remember the little trick I showed you. Great trick. We know that the denominators divide into 12, so let's reduce first and then multiply by the top. 12 over 4 reduces to what? 3. Okay, good. So we end up with 12 over 4 reduces to 3, which I'm going to multiply by the top, and what's that give me? 9x. Good, right? 12 over 3 reduces to 4, which I'm going to multiply by the top and get minus 4y. And then over here, 12 times 1 is just 12, right? We're good. Done. We followed all the rules. Okay, greatest common factor is 1. They're all integers, A, B, and C, and A is greater than 1. Okay, so on your e-ticket, please just do the ones in the first section that have boxes around them. So just 2 and 4. I want to see you do this. I'm going to make the rounds. Okay. Next issue. Okay, so your, oops, it's frozen. Oh, what did I do? Oh, something little dumb.
Oh my. Rookie. Next movie's gonna crash, watch.
I know, probably jinxed it. Gosh. What did I push? There we go. All right, so next issue. The form you're probably most familiar with, slope-intercept form. Right. So what's slope-intercept form? Y equals, there you go, we all remember that one, right? Y equals mx plus b. If we want to, we could probably write it in function notation. But this is the one that we're used to, just y equals mx plus b. We're talking about linear equations. What is m equal to there? And y equals mx plus b, what's m? Slope, there you go. So m is the slope and b is the, all together? Intercept. Which intercept? The y-intercept. Okay, so remember now, the slope, just brief, you guys have dealt with slope for years and years. Slope is just the constant rate of change between points. So we always want to think rise over run, right? Slope is rise over run. So going between 2 points, I can always make a slope triangle, and I'm going to rise vertically and run horizontally, okay? So there are 4 different kinds of slopes, and let's just look at what each one means about the line, how each slope impacts what the line looks like. So what if we have a positive slope? What does that tell you about the line? It doesn't tell you anything exact about the line. There's an infinite number of lines that all have positive slope, but each of them has what in common? It goes up to the right. If you're going in the positive x direction from left to right, you go up a hill, right? You go up upwards. So conversely, what if it's negative slope?
Down to the left.
Down to the left. Good. Okay, now the two that are a little bit weirder. Okay, so what if you have 0 slope? So what now?
Flat.
Flat. Moving flat, but which flat? Is it flat vertical or flat horizontal?
Vertical. Horizontal.
Horizontal. Horizontal.
Yeah.
Now let's talk about why. Okay, because that's one of those things, like how many times have I said stuff like this? Don't just remember that, because you'll forget it, right? Let's attach it to something so we can remember it. Well, the concept we attach it to is just the rise over run concept, right? So if we're calculating the slope of a graph, just any old graph, I pick 2 points on the line, slope of a line, and we got our rise and we've got our run. That's the rise, that's the run, correct? And whatever the ratio of those is, rise divided by run always gives us the slope. Now pick 2 points on a horizontal line. So there's my 2 points. What's the rise? 0. The run is, who cares? The run is just some number, but if I ever have 0 divided by a number, what's the answer? 0. There you go. So that's 0 must mean, 0 slope must mean 0 rise. Okay? Make sense? Now what about undefined slope? Well, what's the only one left? What must that? It's got to be vertical, but more importantly, let's talk about why it's vertical. So if I take 2 points on a vertical line, they have rise, but what's the run? 0. Now what's one of our only rules for numbers? We can't divide by 0. You can't do it. It's not allowed. So because the run, in this case, is 0, we're dividing by 0, that's not allowed, and so it's undefined. There's no number for that slope. Okay? All right, so last issue for today is we're going to look at 2 examples. Now I'll let you practice this a little bit, where we're just going to write the equation in slope-intercept form and then graph it. And these aren't hard, but I want to prepare you for when they do get a little bit harder by thinking about a strategy. It's the same strategy all the time once we get our equation. So the first one is, it's really simple. What's the only thing I have to do to put that in the slope intercept form? John, say it again. Plug in, well, hold on now. I've got f of x equals negative x plus 2. I mean, it really isn't, but what's our more familiar version of slope-intercept form? Instead of f of x, y. Yeah, so we'll just change it to y equals mx plus b. Now, by inspecting this, in math we say we can, the answer by inspection just means that you're going to look at something, and by looking at it you can tell. So what is the value of m by inspecting that equation? Negative 1. Good, it's negative 1 because the slope always corresponds to whatever's in front of x, right? And a negative sign just means negative 1 times. So m is 1. What's b? Say it again? Positive 2. Which means that implies a point, right? That tells us that b is a point with what coordinates? 2. Which ones? There's 2 coordinates, an x and a y. Y is, which one? 2 is y, good. And 0 is the x coordinate, isn't it? Because we're going over nowhere but up 2 on the xy plane. Okay, so how do we do this? Every time we graph a line, there's really just 3 simple steps to follow, okay? Step 1 is anchor point. So you need a point to start with. We'll call it the anchor point. Step 2 is we're going to get a second point. We're going to use a slope triangle. Put that all in one line. Oh gosh. Use a slope triangle to get a second point. There's step 2. And then once I got the 2 points, it's simple. I just connect and extend, create the line. Okay. So what's our anchor point with number 8? Yeah, 0, 2, right? The y-intercept. We start with the y-intercept, which is right there. And now what? Go up 1. Okay, so I'm going to go up by negative. I'm going to rise by negative 1, which just means I'm rising down, right? So I'm going down 1 and right 1. Because if I want to write that slope, I want to write the slope as a fraction. Anytime I have an integer, what's the denominator always going to be? What's the, like 7 as a fraction is what? 7 over 1, right? If there's no denominator showing, it's an invisible 1. So I get negative 1 over 1. So my rise is going to be negative 1, and my run is positive 1. And that gives me a second point right there. Step 3, connect and extend, and we're done. And there you go. There's our line. Okay? All right, so what about something like this guy down here? A little tougher. Now there is a way, this is in standard form, right? That second line is in standard form. We can graph from standard form. It's not hard to do, but we're not going to do that today. For today, we're only graphing from slope-intercept form. So what do we have to do to put this into slope-intercept form? Subtract x, and then what? Divide by 3. Good. Now what'd you do? You isolated y, right? So here's the recipe for putting a line into slope-intercept form. There's really just 2 parts. You isolate y and then simplify if you need to, right? That's it, every time. To put a line in y equals mx plus b form, 2 steps. Isolate y is step one. Step two, simplify, if you even need to, okay? All right, you already told me the steps here, so let's look at those. Now I'm gonna, you said subtract x first. So that's gonna give me a 3y on the left. Now I've got a negative 15 minus x. That's the same thing as negative 15 plus negative x. Which one should I probably put first? The x or the negative 15? The x, because I wanted an mx plus b, so we want the x term first, and then the 15. Okay, last step you told me divide by 3. That's correct. If we divide by 3, that's going to be good. Over here on the left side, I get my y, which is what I want. What about the right side? Ah, there you go, good. So I'm dividing each term by 3, and look at this part right here. I've got, what is that slope? There you go, negative 1/3 x, and then minus 5. You good? Do we have time?
Yeah.
Okay, so the, no, probably enough time. Hang on to those, hang on to the e-tickets. We'll finish those up tomorrow in class. Okay, there's a 6 problem assignment online. You might want to get a jump on that. I'm going to give you a day later in the week, a work day / retake day later in the week. But to be eligible for